Hi everyone, hope you're okay. This is TG Tips and I do maths and educational videos. Today will be another maths tutorial on standard form, so make sure you have a calculator with you for this one and we'll get straight into the video. Before I go ahead, make sure you give this video a thumbs up if you find it helpful, subscribe to my channel for more content and share this with someone who you know needs help. Okay, let's go. Okay, so before I go ahead, as always, my email address is at the bottom of the screen there, so if you have any questions or any video requests, please send them to that email, and we'll go ahead. As I said before, you do need a calculator for this, so make sure you have one with you. Some of the questions do get a bit tricky. What is standard form? The definition basically is a simplified way of writing numbers mathematically. So standard form is the standard way that mathematicians present numbers, sometimes referred to as scientific notation. Here's an example. We have a number here. If we count the zeros, we can work it out to be 20 million. But as you can tell, it is a bit difficult to be accurate when you're just counting zeros. So standard form would be a way to write this more easily. In standard form, we would write this as 2 times 10 to the power of 7. Obviously, if you don't know what standard form is, it doesn't look like it's very helpful. But if every number is written in this way, you can tell the size of the number much easier. So we'll go into the rules of standard form so we're able to understand why I've written it like this. Here are the rules of standard form. So standard form is written in the form of a, which is a number, times 10 to the power of another number. The magnitude of a must be between 1 and 9.99999. Basically, it has to be either 1 or above, but less than 10. And by the magnitude, I mean either negative or positive. So if we're writing a negative number, a still needs to be between 1 and 9.999, because we're speaking about the magnitude, the size of a. Magnitude is another word for size. It can be a decimal. So for example, with the 20 million that we had before, our A in that instance was 2. So we couldn't have put 20 or 200 or etc. It had to be between 1 and 9.99999. The second rule is B can be positive or negative, but B must be an integer. So B can't be a decimal. And the reason that B would be negative instead of positive is if we're representing a decimal number. And let's use our 20 million as an example. We've found that A is 2, so we know that it's 2 times 10 to the power of B. So our B we find by imagining a decimal point after the 2 and working out which way that we're moving it. So because we want the number to get bigger, we would move the decimal place to the right. So if we move the decimal point to the right, the number gets bigger, and if we move it to the left, the number gets smaller. So with our 20 million, we can see that we have 1, 2, 3, 4, 5, 6, 7. So we have to move the decimal point 7 times, so it's here. So it would be 2 times 10 to the power of 7. Now the decimal point comes here because we think of it in terms of place value. If you remember from primary school, I think they teach you that we have the units, tens, hundreds and thousands and etc. columns. So what we're doing here, we're multiplying it by 10 7 times, as we learned through the indices before. 10 to the power of 7 is 10 multiplied by itself 7 times. So if we multiply the 2 by 10 multiplied by itself 7 times, we're basically multiplying the 2 by 10 7 times. If I was to write this in number form, we would have 2, we would see that this equals 2 times 10 times 10 times 10 times 10 7 times, basically. And as we begin to multiply the 2 by 10 all these times, it gains a 0 at each place. And that is why standard form works. If we go through the rules again with another example, here we have Here we have the example of 0.0002. And we said that the magnitude of A must be between 1 and 9.99999. We want to find a number in this that is between, I'll say 1 and 10. We know that we can't choose 10, but I'll say between 1 and 10. So looking at 0.0002, we would choose 2. We can't use 0. So our A would be 2. And now we'll move on to working out the B. B can be positive or negative, but must be an integer. So our first part is 2 times 10 to the power of something. At the moment, we have a 2, but we need it to become 0.0002. So we want to divide the 2 by 1, 2, 3, 4. We want to divide the 2 by 10 to the power of 4. B would be minus 4. If we do 10 to the power of minus 4, that becomes 1 over 10 to the power of 4, which is 1 over 1 with 4 zeros, 10,000. Sorry about that. So when you multiply 2 by 1 over 10,000, you divide 2 by 10,000, which is why it is 2 times 10 to the power of minus 4. Again, if we look at it as we did before, we are moving the decimal point. So currently the decimal point is here, and we want to move it by B number of spaces so that it becomes this number here. So we would start with the decimal point here and move it by 1, 2, 3, 4 spaces, and it would come here, and then we just add the placeholders. We'll go into more examples and hopefully we should see it fall together more nicely. This example says, an average football pitch is 7,140 square meters. What is this in standard form? So we have the rules here on the right hand side. I've written them a bit more concisely. So standard form is written as A times 10 to the power of B. A has to be greater than or equal to 1, but less than 10, and B is an integer, positive or negative. Looking at this number, to write A as a number between 1 and 10. So we have 7 here, but we can't forget about the 1 and 4. But we can't write 714. So we would write 7.14 because that is the only number that is between 1 and 10. We have our A as 7.14, and we're multiplying that by 10 to the power of B, where B is a positive or negative integer. So the first thing that we think of is, do we want this to get bigger or smaller? Well, currently we have 7.14 and we want 7,014. So we want it to get bigger. So we know that we're moving the decimal point to the right. And we know that B is positive because that will make it bigger. And we are now going to count how many places we're moving the decimal point by. So we need to move it 1, 2, and 3 places. So if we move it 3 places, the point will become here, and we need to just add 1 placeholder there. So it will become 7,140. So that's 1, 2, 3. So we multiply 7.14 by 10 to the power of 3, which would give us 7,140. The best way to think about this, to check your answer, is we have 7.14 and we multiply it by 10 to the power of 3, which is 1,000. If we multiply 7.14 by 1,000, so it becomes 7,140. The first thing that you need to do is just to find the A. Once you have the A, it's much easier for you to think about. I know it seems a bit like, what's the point in doing all this? But this is very useful for comparison. So if you're comparing bigger or smaller numbers, it's a lot easier to see it in this standard form than it is to look at it as numbers. So we'll move on to another example. Again, I'll keep the rules there for you. So this is from Corbett Maths. They have a paper on standard forms. I'll link it in the description box at the bottom. It says, the table gives the circumference in meters of planets in the solar system. The circumferences are given to an accuracy of 3 significant figures. I've not put all the planets on because I thought it would take way too long. I just put 3 on there so we can compare them and get a better idea. So we have Mercury, Venus, and Earth, and we have their circumference written in standard form. The question is, which planet has the largest circumference? The question actually says that you can use a calculator. We'll just quickly use a calculator now so we can see it all in practice. So if you get your calculator, you can actually just put in the standard form versions into your calculator and it will give you the numerical value. So the first one says 1.54 times 10 to the power of 7. And that gives us 154,000,000. Now the way that I think of it, if I didn't have a calculator, is we have 10 to the power of 7 and we have 2 numbers after the decimal place. So I know that two of these jumps are going to be used to jump to make the 5 and the 4 come to the left of the decimal point. And then I know I have 5 more jumps left, so I'd know that there's 5 zeros. I'll explain that a bit more on the next one. So here I have 3.81 times 10 to the power of 7. So if I have 381, I've moved it by 10 to the power of 2. And I need to do 5 more jumps, so I know I'm doing 5 zeros. And again, on the fourth one, it's 4.01. Again, you can put it in your calculator. I'll just do it as it was. So it's 401 and then 5 zeros. We can see that Earth has the biggest circumference. So our answer would be Earth, because Earth is the biggest number. But one thing that really stands out to me with this is the fact that for me, it's a lot harder to compare the numbers when they're this long. I would rather look at this and see that, okay, all of the numbers are between 1 and 10. So I know that I am looking for the one with the highest power of 10, but they're all to the power of 7, so they're all going to end up the same size, if I can say. The only thing that we have to look at this is if we were to look at the A's in all of these standard forms, we would see that 4.01 is the biggest. So immediately I would know that Earth will be the biggest number because it's the biggest. But on the next example, which I have here, it is negative. But again, we can use the same principle. We have 3 different standard forms. How do we find the smallest? So it's the same principle as the first one. The first thing that you would do is immediately look at the power of 10. Look at the B. So we want the smallest one. So we can assume that the one with the smallest B value would be the smallest. So if one of them is being divided by an extra 10, we already know that that's going to be the smallest. So this is -3. This is -2, and this is -2. So we can see that these two, B and C, are going to be the same size in terms of decimal places. And A is going to be divided by an extra 10, so A would be the smallest. The question doesn't ask us to do it, but let's say we want to find out which one is the smallest between B and C. So we know that B and C are going to have the same number of decimal places. But what we would then look at is the A. So we would choose the one with the smallest A, and we know that that's going to be the smallest. So B is 3.72 and C is 4.79. So we can assume that B is going to be the second smallest, and that leaves C as the largest. We can work out the A by doing 4.6 times 10 to the -3. So if we're timesing by 10 to the -3, we're timesing by 1/1000, which is the same as dividing by 1,000, which is moving the decimal place 3 spaces to the left. So we have 4, 6, we have 1, 2, 3. So the decimal place is now here. We add a 0 before the decimal place and fill in the spaces. So it's 0.0046. B is 3.72 times by 10 to the power of minus 2, which is timesing by 1 over 100, which is just dividing by 100. The decimal point was here, but we're moving it 2 spaces to the left. So the new decimal point is there, and we fill in the space and we get 0.0372. C was 4.79 times 10 to the power of minus 2, which is the same as dividing by 100. We would write the 479. The old decimal place was here, and we're moving it 2 spaces to the left. It's going to be here. We fill in the gap, and we can see that the new value is 0.0479. Again, looking at these, the 4 is bigger than the 3, so we can see that C is bigger than B. And this was a lot easier to deduce by looking at the power of B and then looking at A. And that is how you determine which ones are bigger and smaller. But I'll just go through a summary for you so we can summarize all the rules. Remember that we're moving the decimal point, not just adding or removing zeros. Let's say we have 1.370 times 10 to the minus 3. Now here we're actually dividing by 1,000, but some people might be tempted to just do 0.000137, which isn't right because we're not adding 3 zeros, we're dividing the number by 1,000. The next point to remember is the rules. So again, standard form is written in the form of A times 10 to the power of B, where A is a number greater than or equal to 1, but less than 10, so it can't be 10, and B is an integer. So B can't be a decimal. And the last one is to watch out for existing decimal places. This is a really important one. So if we have so this one is really important. So let's say we have 1.37 times 10 to the power of 5. So we have to remember that we're using 2 of these spaces to make the 3 and the 7 whole numbers. So we have to remember to move these numbers, these existing decimal places. We can't just ignore the fact that there was a decimal there. Hopefully that makes sense, guys. I'm really sorry if it was a bit of a unclear explanation. Please let me know if it didn't make any sense. I'll be more than happy to do this again because I do think you deserve it to be clear. But yeah, that is everything I could say on the topic. I just have some standard form questions linked in the description box for you to have a go at. I've also made a question paper with pointless facts, but they're all written in standard form, or they're for you to write in standard form. That will also be in the description box, and it will be linked to the Google Drive folder that I have opened for you guys. Again, my email address is at the bottom, so if you do have any questions, let me know, send them over to me, and I'll be happy to help. And thank you so much for watching, guys. Give this a like if you find it helpful, subscribe for more content, and I'll see you in the next video. Thank you. Bye.